The purpose of this presentation is to inform the public about the Department of Defense's current and historical activities at 12 Atlas F missile silos that are located near Roswell, New Mexico. The Atlas missile program was developed to serve as a deterrent against attacks on the United States or its allies. During the missile program's brief operational period from 1960 through 1965, the Air Force assigned the Atlas missiles to 10 parent air bases located throughout the United States, and then staffed and maintained 123 Atlas missile launch complexes that were located within a 40-mile radius of these parent air bases. One such parent base was the former Walker Air Force Base, which is located in Roswell, New Mexico. Its 12 Atlas F missile silos are located within a 40-mile radius of Walker Air Force Base. Currently, the former silos are owned by non-DoD entities. Since 1990, the Albuquerque district of the U.S. Army Corps of Engineers has been actively searching historic records documenting government activities at these missile silo sites. Historical documents indicate that the Atlas missile silo consisted of three components: the missile, the launch complex, and the maintenance area at the parent air base. Historical launch complex operational activities during the 5 years that the Atlas F was operational can be divided into three distinct phases: construction, operation, and disposal. Atlas F, the most advanced of the Atlas series missile, was activated in 1962. Atlas F missiles were designed to be stored vertically in hard or silo sites, completely underground. The Atlas F missile was 82.5 feet in length, 10 feet in diameter, and weighed 267,000 pounds when fueled. In order to launch the missile, it would have been fueled, lifted by the launch platform to the mouth of the silo, then fired. Construction of the 12 Atlas launch complexes occurred between 1960 and 1961. Civilian contractors performed all construction activities under the direction of the U.S. Army Corps of Engineers. A typical silo layout consisted of above-ground and below-ground structures. Above-ground structures included the personnel entrance to the Launch Control Center, a water treatment building, water storage tanks, a cooling tower, two 75-ton concrete silo doors, and petroleum, oil, lubricant, drainage, and fill lines. Underground structures included a fuel storage tank, a catchment storage tank, water storage tanks, the Launch Control Center, and the missile silo. Each underground silo was constructed of reinforced concrete, approximately 175 feet deep and 52 feet in diameter. A tunnel connected the silo to the Launch Control Center. The Launch Control Center consisted of two levels, Level 1 containing the crew living quarters, and Level 2 containing the work area where the launch control equipment was located. Inside, the silo is an 8-level steel crib suspended from the silo walls. Mounted to each level are various storage tanks, control cabinets, and other equipment needed to support the Atlas missile system. The 579th Strategic Missile Squadron, stationed at the former Walker Air Force Base, began operating the Atlas F missile silos between 1961 and 1962. The 579th Squadron had two crews, a missile crew and a maintenance crew that were responsible for staffing, operating and maintaining the systems at each launch complex, as well as performing maintenance on the missile and its warhead in secure buildings at the parent airbase. At the launch complex, the missile crew performed minor adjustments and scheduled maintenance on missile support systems located within each silo, which included the propellant loading system, the hydraulic system, and the power generation system. The propellant loading system was utilized during launch exercises to load the missile with propellants before being elevated to firing position. Tanks located on the 8th level of the silo included helium, gaseous nitrogen, liquid oxygen, and a high-grade form of kerosene named RP-1 fuel. RP-1 and liquid oxygen were used as propellants in the Atlas F missile, and gaseous nitrogen and helium were used to pressurize the missile. Fuel and gas tanks were refilled when needed by supply trailers on ground level. The hydraulic system was located on level 2 of the silo. Hydraulic fluid was used to raise the missile and to operate other equipment such as the 75-ton concrete silo doors and the silo elevators. The power generation system consisted of diesel-electric generators located on the 5th and 6th levels of the silo. 4-inch deep drip pans were placed beneath generators to prevent leaking fluid from coming into contact with liquid oxygen tanks. Storage tanks provided fuel and lubricating oil for the generator's diesel engines. A tank stored dirty oil, which was discharged at the top of the silo by a transfer pump. At some of the silos, New Mexico's water table presented engineering challenges during site construction as groundwater infiltration became a problem. To deal with the liquids in the silo and launch control center, 2 sumps were installed at each complex, one at the bottom of the missile silo and one at the bottom of the launch control center. Any liquids collected from the silo were pumped to the surface through a 6-inch line that discharged into a French drain. Liquids from the launch control center were pumped to the surface and discharged into a septic leach field. Sites with water treatment plants also had evaporative ponds that received backflush water from the treatment plants. Liquids that may have been discharged at each launch complex include RP-1 fuel, diesel fuel, hydraulic fluid, and water. Solvents and cleaning products were generally stored at Walker Air Force Base and brought to the silo only when needed. During the 3 years that the Atlas F missile silos were operational, 3 launch complexes, 1, 2, and 5, were destroyed due to explosions. The General Accounting Office and a Congressional Oversight Committee determined that these explosions occurred during propellant loading exercises. In 1964, as the Titan II intercontinental ballistic missile became operational, the U.S. Air Force phased out the Atlas missile program. Deactivation at the missile silos occurred in 3 phases. First, missile equipment, fuels, gases, and other mobile equipment were removed from each silo. Second, salvage contracts were issued for the removal of remaining equipment and materials, and most of the remaining equipment was dismantled and removed. Finally, each launch complex was declared surplus property and was transferred to non-DoD entities. As part of the Corps' inspection process, it evaluated the historical activities that occurred at the 12 missile launch complexes near Roswell, New Mexico. At each silo, 5 areas were identified for further inspection: the silo sump outfall, the underground storage tank area, the septic leach field, and groundwater and silo water if present. Circular site inspections have been completed at silos 1, 3, 4, 5, 6, 8, 9, 10, and 12. Circular site inspections will be conducted at silos 2, 7, and 11 when access to the sites is obtained from the property owners. Potential contaminants of concern are organic solvents such as carbon tetrachloride and trichloroethylene, petroleum-based products, and polychlorinated biphenyls. To communicate the inspection results and to establish a two-way dialogue with the local stakeholders, the Corps has initiated a public involvement program. As part of this program, the Corps is releasing the findings of its preliminary assessments and circular site inspection reports so that the community is familiar with the Corps' inspection activities and results. Fact sheets regarding the sites have been mailed to community leaders and interested parties. If you have information about site activities, would like to comment on the findings of the preliminary assessment or circular site inspection reports, or would like to join the mailing list, please contact the U.S. Army Corps of Engineers Albuquerque District Public Affairs Office through the U.S. Postal Service or by calling 505-342-3171.